Bismillahirrahmanirrahim. Assalamu alaikum. I welcome all of you in the virtual meeting of 6th week. And in this week's virtual meeting, we will be covering chapter 4. I hope that in your face-to-face classes with your own respective teachers in your campuses, you may have completed chapter 3 or maybe very close to completing chapter 3. As I mentioned in my previous virtual class, the purpose of these virtual classes now for you is to provide you a second reading of your content. So if we study chapter 4 here, you will also be studying the same chapter with your own instructor. You can clear your confusions, you can ask questions about the chapters that we are studying here, and you can assess these along with the content that you have studied with your teachers. You can ask questions to me as well as your own respected faculty members so that you understand a better insight into the contents that we are studying. Today, in today's 1 hour, inshallah, we will have a discussion about chapter 4 of your book, and this chapter is about computer software. In chapter 3, you may have studied what the hardware we use in our today's world. And in chapter 3, you studied that hardware can be divided into two parts. One is the computer itself, that is processor, and the other is peripherals, which mainly comprise of memory, input devices and output devices. And then the memory is further divided into 4 major classes: register memory, cache memory, RAM and ROM. And then there are many kind of variants of all of these memories. That is also discussed in chapter 3. In chapter 4, we are going to talk about the various kind of softwares that are available to us. So the learning objective of this course is to familiarize you with various kind of softwares and what are their utilities. Starting from slide number 5, slide number 5 is very important. Slide number 5, you have been told that all of the softwares that we use can be divided into 2 major categories. One category is called system software and the other category is called application software. What is a system software? A system software is a kind of software which actually doesn't do anything directly for you. Means a system software is not management information system. A system software is not an office automation system. It is not a web browser. It is not a knowledge management system. Nothing of these. But system software is a software which runs your computer, which runs your machine. Your applications run only if your computer has appropriate system software on it. If it has appropriate system software on it, your application software can communicate with the computer. Because if your application software cannot communicate with the computer, the hardware, they cannot do their tasks. They cannot get the resources. They cannot get the time that is required to perform the tasks. Right? So system software are the kind of software which manage your computer and your applications. Without system software, you cannot run your applications. Application software, on the other hand, are that kind of software which perform tasks for you. As you can see in the slide, application software are the programs that perform a particular function for you. So your management information system or your management information systems will be application software, and the software which helps them run on your computer will be a system software. Application software can be further divided into many categories. From slide number 6, we are going to see various kind of categories of application software. By now we remember there are 2 kind of softwares: application software and system software. Within application software, one category of application software are general purpose application programs. General purpose application programs are such kind of application softwares which can be used by anyone for their own jobs. So general purpose applications are not like if I am a university teacher, then I will be using the same general purpose application that a doctor will be using. And maybe an engineer, an architect are also using the same kind of general purpose application. Take the example of MS Word. MS Word is used by me, MS Word is used by you, MS Word is used by doctors, MS Word is used by architects, by engineers, by everyone. So it's a general purpose application program. It contains information processing jobs for end users, all of the end users, not limited to any particular group of people. So MS Office, spreadsheet, PowerPoint presentation, Word, Excel, all of these are general purpose applications. Then there are such kind of applications which are used by a particular group of people. For example, there may be a software which only doctors use. There may be a software which only software engineers like you and me use. For example, there is a software called Visio. There is a software called Rational Rows. With the help of Visio, with the help of Rational Rows, you can create models of object-oriented application, which can then be automatically transformed into code. So, what will be Rational Rows? Rational Rows will be an application-specific software. There is another software called MATLAB. MATLAB is an application-specific software. It performs mathematical modeling and mathematical simulation. It is called an application-specific software. The purpose of application-specific software is to provide support for a specific function, for a specific job. So, MATLAB is used for one purpose. It is not used by everyone. Doctors will not be using MATLAB. Similarly, if there is some software which can help doctors running their hospitals, will not be used by software engineers. Rational rows will not be used by mathematicians. These are called application-specific softwares. Then there are custom softwares. Custom softwares are such kind of softwares which are for a particular job being performed in a particular organization. If an organization X wants a software to be developed only for them, for example, your organization wants developers to create a totally new management information system for them, it will be called a custom software. But if the same task is performed in an organization by using a software that they have bought from the market, and the same software is being used by many others as well, it is called commercial off-the-shelf software. COTS, commercial off-the-shelf software. This is not a custom software. If your organization decides to get a new management information system or a new financial accounting system developed for them, it will be a custom software. But if your organization wants to use a SAP solution, it will be a COTS solution because they have purchased it from market. Your competitors can also purchase it. Anyone can purchase it. These softwares are called COTS software. Open source softwares are such kind of softwares which you buy or you download freely, but you have the right to change it altogether. You have the right to modify it. You have the right to reuse it. You have the right to change it. The company, the organization, the developers who have made the software have given you the software, the documentation, the design, and the code. So you can change it just as you need it. This is called open source software. You have full rights. You have full authority over the software that you are using. In slide number 8, various kind of softwares, both application software and system software, which are used for different purposes, has been listed. This is a very important diagram on slides. What are business application software? Business application software are such kind of application software which can help you doing any particular part of your business. These business application softwares are which are specifically for the purpose of doing business. Business application softwares are management information systems. As you see here, some examples of management information systems. Customer relationship management. This is the kind of management information system which can help your organization manage relationship with the customers. So, transaction processing systems will be an example of customer relationship management. Transaction record systems will be an example of customer relationship management. Customer record management systems will be a part of customer relationship management. All of these are management information systems which handle the need of customers. On the other hand, there is another kind of information systems which are called enterprise resource planning systems. These are the kind of management systems through which you manage your business. With the help of customer relation management, you manage your customers and various kind of operations associated with the customer. With the help of ERPs, you manage your organization. For example, inventory management. For example, human resource management. For example, financial accounting. All of these kind of systems are called enterprise resource planning systems. Then there are the kind of management information systems through which you manage the supply side of your organization. For example, tracking the delivery of goods to your inventory. For example, tracking the contracts that you have awarded. For example, managing relationships with your suppliers. All of these kind of tasks are performed by supply chain management. So, business application softwares are application softwares which are specifically designed to help in your business. All the management information systems are called business application softwares. As you look in the next slide, these business application softwares are, as we mentioned in chapter 2 as well. There are two kind of purposes for which business application softwares are. One is the core activity, that is organizational activity. Any management information system has to manage and automate the operations of the organization. So all of the activities that I mentioned in the previous slide, financial management, accounting, human resource management, inventory control, customer management, transaction management, various kind of activities. Your business application softwares have to automate all of these activities through management information systems. Then there is second part, that is value added. If your software has the support of data mining, from slide number 12, general purpose application software and some other kind of software we start giving explanation about them. We'll ask questions at the end of the class. Then you can ask your question. Software suites and integrated packages. What are software suites and what are integrated packages? If you get a software which when you install comprises of many softwares. Take the example of MS Office. MS Office is not just one software. It is a combination of many softwares. It has MS Word in it, it has PowerPoint in it, it has Excel in it, it has Access in it, it has Publisher in it, it has SharePoint. It's a suite. It's a bundle of many general purpose software applications. So that if you want to create a spreadsheet, you still use MS Office. If you want to create a document, you still use MS Office. If you want to make a presentation, you still use MS Office. All of the software which are closely related with each other are bundled together in the form of a suite. It has many advantages. Since all of these are general purpose applications, all of the people can use it. So bundling together in the form of one software can help reduce the cost. How? if you see it, the interface of MS Word and MS Excel, you will see that these interfaces are very common. You have the same kind of buttons doing the same kind of things. If you have made one application, you can use a lot of code of that application into the second application that you want to bundle together. So your cost is reduced, your development cost is reduced. Similarly, instead of buying for the customers or the end users, instead of buying like 7 different softwares, you buy only one software, that is MS Office. So your cost is reduced as well. And your efficiency increases because it is the same interface. The same interface you use for MS Word, the same interface you use for MS Excel, the same interface you use for PowerPoint. So if you learn one software, you learn all of the software. That reduces your training time, and with one constant graphical user interface, your productivity increases. But there are disadvantages as well. The major disadvantage is there are a lot of features which a lot of people don't use. But since it's a general purpose application, so some of the people use it, and the company who has developed the suite has to integrate those functions. Like, for example, if you buy MS Office and your work is to prepare reports, you will not be using Access. But since you have bought the suite, so Access comes with it. You don't use it, but it is installed on your computer. For example, if you are database administrator of an organization, you don't use MS Word, but you have to download MS Word because it is part of the suite. Similarly, take another example. For example, in MS Word, there are hundreds of fonts, but you may use only 2 or 3 of those fonts. The other fonts are useless for you, but those fonts are there because some other people use them. Similarly, for example, when you use MS Word, there is an Arabic language support for you, but you see there is a Chinese language support as well. You don't use Chinese support, but you have to get it because it is there, because some people in China also use Microsoft Word. So there are many features in the application which you don't use, but those are there as well. When there are a lot of features which you don't use, since it is not a custom product, it is a general purpose product, anyone can use it, so it will become a very large software. It will take a lot of disk space. That disk space will never be used by any other product because the suite has occupied that space, but you are forced to give it that space because you have bought a suite. Any suite in which the applications are able to interact with each other is called an integrated package. If you have a few applications which can communicate with each other, those applications are integrated. Like, if you write some data in MS Excel, you can copy and paste that data in MS Word as well. And if you port it from MS Excel to MS Word, if you change the data in MS Excel, the data in MS Word automatically gets changed. You make a model in rational rows and you transport that model, not just copy paste. You transport that model from MS Word to from rational rows to MS Word. If you make any change in the source document of rational rows, that change will automatically be reflected in the MS Word diagram until both of those documents are connected with each other through porting. So this is called integration. Integration helps you in creating one artifact and using it across many different applications, So that is the advantage of this space usage. The major advantage of integrated packages is that if you can create one artifact in one application, you can integrate that artifact with other applications, you will have only one copy. You will not have 10 files, you will have one copy. That will reduce the disk space. If your suite is such that it is integrated, the disk space of files will be reduced. That is major advantage. But if you have an integrated package, but that is not a suite, it means it will have limited applications, so its utility will be less as well. Then there are web browsers. Web browsers are such kind of general purpose applications which can help you communicate on World Wide Web. Such kind of general purpose applications which can help you communicate on World Wide Web are called web browsers. Now, web browsers are not just the web browsers that we normally associate with. Like we say Internet Explorer is a browser, we say, for example, Chrome is a browser, we say Firefox is a browser. All of these are browsers, but then there are some such kind of browsers as well which are not traditional browsers, but those help us communicating on World Wide Web. For example, Skype is a categories of web browsers. Some web browsers are such that those web browsers are system software specific. For example, you take the example of Opera. Opera is specific to Mac operating system. So if you buy a Mac computer or if you buy an Apple iPhone, Opera is pre-installed on it because it is specifically designed for Mac operating system or iPhone operating system. Similarly, you will see that if you buy Windows operating system, Internet Explorer comes pre-bundled with Windows because it is specifically designed and customized for Windows operating system. So if you, similarly, for example, if you see Chrome, if you buy an Android operating system based handheld device, you see that it is pre-bundled with Chrome because Chrome is designed for Android operating system. Now if you want to install another operating system on your computer, another browser on your computer, it doesn't come pre-bundled. Like if you want to install Opera on a Windows platform, you will need the permission of Windows to run Opera, right? So it is specific to a particular kind of system. Some browsers are such that those browsers can run on any platform, such as Firefox is not a system software specific browser. It can run on Windows, it can run on Apple, it can run on Android, it can run on anywhere. So these are two major categories, one system software specific browsers and the other system independent browsers. Word processors are such kind of applications which can help you create documents. Like MS Word is a word processor. So it is with word processor you get a lot of facilities. As you can see, with word processor you can write the document, you can format the documents, you can edit the documents, you can correct the spellings of the documents, you can correct grammars of the documents. There are dictionaries associated with word processors. The purpose of word processors is to help you create documents, files. When we make another software which can transform those documents into publishable books, they are called desktop publishers. So if you create a document and with the help of a software you can create the binding of that document, you can create the title of that document, you can create the flap of that document, you can create the back page of that document. This software is called a desktop publisher software. Desktop publisher softwares are usually word processors with additional support for creating books out of those documents. Spreadsheets are such kind of software which can help you storing mathematical data, arithmetic data, numerical data. So when you store numerical data, the purpose of that kind of software becomes to use that numerical data for the purpose of analysis, for the purpose of modeling. Just like when you use Excel sheets, when you store the numbers in it, you see that you can apply formulas to get some more numbers out of them. For example, you can apply the formula to find average. You can apply formula to find mean or median or some such kind of. What is the purpose of getting all of this data? To perform analysis, to see what does that data mean. Similarly, for example, with the help of Excel, if you store data, numerical data on the spreadsheet, you can create graphs. What is the purpose of creating those graphs? The graphs are models. With the help of those models, you can analyze the data and plan about the future. So what if scenarios you can do? So these are the major purposes of spreadsheet solutions. Then there are the kind of application softwares which can help you creating presentations. The presentation's purpose is to convey the idea, to present your text and numerical data graphically, like I am making these slides. The purpose of these slides is to create a summary of the whole chapter in the form of diagrams, in the form of graphs, in the form of text that is written, so that I can convey my idea forcefully. Instead of writing a whole page, I just write two most powerful sentences of that page, and then I talk and convey to you the meaning of the words that are written here. This is called intuitive comprehension. That instead of reading and understanding things, you read summary. You look at the diagram, you talk with someone, and you understand the meaning. Intuitive comprehension, quick understanding. So presentation softwares are for the purpose of quick understanding of the text. Then there are such kind of general purpose applications. All of these applications become part of your overall management information system in the organization that we are discussing right now. Personal information managers are that kind of softwares which can help you manage your information. Now, in today's world, you have a lot of information that you have to remember. For example, let me give you a small summary. For example, you have a lot of passwords to remember. You have a password for Blackboard, you have a password for your email, you have a password for your Facebook, you have a password for your ATM, you have a password for your credit card, you have a password for your Facebook, you have a password for your Twitter, and so many other passwords. How do you remember all of those passwords? One, for example, you have to do a lot of things every day. You have to go to market to buy groceries. You have to go to meet someone who is ill. You have to attend your class. You have to do particular tasks in your office. You have a lot of things on your mind that you have to do every day. Similarly, for example, you have to remember dates. There's a particular date when my class is held. There's a particular date when the class of programming is held. There's a particular date when the class of HCI is held. For example, you have to remember birthdays. For example, you have to remember when the midterm will be held. You have a lot of information. What I want to say is, you have a lot of information that you have to remember. Now, if you have to remember all of this information on your own, you will forget a lot of things. For example, maybe today was the birthday of your friend, but you forgot to wish her a happy birthday, right? For example, today you had to go to hospital, but you forgot because you were working and you forgot that you had an appointment with your doctor, right? You try to log in on your Twitter account and you say, oh, I forgot my password. In today's world, you have to remember a lot of information. Actually, this is a phenomenon in science and computer science that is called information overload. In today's world, we have an information overload. So we have the kind of software which manage this personal information for us. You may have seen some such kind of software which record and lock your password. So if you forget the password, you can open that application and see the password that you forgot. You have calendars. For example, with the help of calendars, you can understand what you had to do on a particular day. You have reminders. Reminders remind you. These are all the kind of personal information managers. Then there is another category of software called groupware. What is a groupware? A groupware is a kind of software which can help a lot of people work together So let me give you an example. If I am using MS Word is not a group page. If I have an MS Word and you have an MS Word, someone else has an MS Word, we cannot combine together a document with the help of that document, so that we cannot combine that document in such a way that all of us can work on that document together. Everyone will be doing individually their way. But let's take the example of this blackboard. Now this blackboard is a group where if I am writing something on blackboard, I have written a note and one of you says that I want to have a point on this note. I give you the power and you can change something, you can write on it, you can add your comment on it at runtime. So a lot of people can work together. You have a presentation, you are delivering that presentation to me, and while you are delivering that presentation to me, I can scribble my notes on your presentation and you can see as well when I am writing. So if a lot of people can work together at one document at same time, at one artifact at same time, with the help of a software, that software is called groupware. Blackboard is a groupware, but Microsoft Word is not a groupware because it cannot help you work together in the form of a group. Now on slide number 18, a new concept is given, a very important concept. When you buy a software, you must remember one thing. Most of the times, you are not buying the software. The software remains property of the organization which has developed the software. So like if you say that you have bought MS Word, you haven't bought MS Word. You have bought the license of MS Word. Like when you, if MS Word, you can use it any way you like, then you have bought it. But you see that when you download and install MS Word or buy MS Word from market and install it on your computer, when you install it, you get a message from MS Word that it will be installed only after you accept this license. When you accept it, MS Word is installed. It means that you and the organization who have developed MS Word are entering into an agreement through that license. You will use MS Word only according to that license. But the control of MS Word will remain with Microsoft. You only have bought the license of using Microsoft Word. You haven't bought Microsoft Word. On the other hand, if you get an open source software, you don't get a license for it. You can use it just the way you want. You can change it, you can add something into it, you can modify it, you can delete the components which you don't want, you can create your own components and add those into the product that you have bought. There you haven't bought the license, there you have bought the product. When you buy an open source product, you buy the product. When you buy a product which is not open source, you haven't bought the product, you have bought the license of using that product. So one, licensing is different and buying is different. When you buy something which you cannot change, you have bought the license to use it only. When you have bought an open source, you have not bought the license, you have bought the product. One. Second, with the emergence of more powerful computers, today it is possible for you not to install software on your computer. When you install software on your computer, it takes resources of your computer. It takes disk space of your computer. It uses your operating system. Now if you have a web browser, if you have a word processor, if you have a spreadsheet, if you have an Access database, etc., etc., you have a lot of software. All of those softwares are consuming your disk space. What if there is a mechanism when you don't need to install products on your computer, you can use them remotely using World Wide Web. If the software is installed by someone else, and you use that software remotely using web browsers, this is called service. This is not a product, this is a service which you are using. So when you see the phenomena of today, that is cloud computing. Now let me give you an example of cloud computing. Google Docs. You have an option of installing MS Office on your computer and creating your documents, or you can go to Google Docs online. Now when you are going on Google Docs, you have not installed Google Docs on your computer. It is not taking any of your disk space. You are accessing Google Docs using internet. All the documents that you create are stored on Google Docs. So you don't need to consume your memory and your hard disk on storing the documents. The documents are stored by Google Docs servers on Google Docs servers, and you can access them anytime. This is called cloud computing. Let me give you another example. For example, most of you have bank accounts, and almost all of you may be using internet banking as well. Now with the help of internet banking, you can pay your bills online. Now the bills are for the facilities which are not run by the bank. For example, electricity. Electricity is not provided you by the bank. But bank has created a cloud for you as well as for the electric company. You log on to your internet banking on World Wide Web. You access the service of online payment. The service, you have not installed any software on your computer. When you install a software on your computer, it is a product. When you use a product using World Wide Web and product is hosted by some other organization on their computers, it is called service. This is application service. So you log on to your bank account, you go to the online payment of bills, and you pay your bill online. This is a service on the cloud. So cloud is when the services are provided online. You don't need to install computer or install product on your computer. You access the services using the service provider on World Wide Web. So Google Docs is a cloud computing service. Similarly now, MS Office has the facility to create documents online. There is a cloud service. Amazon has its own cloud. Your banks have your own clouds. So cloud computing is when you don't install software, application softwares on your computer, you only use them using World Wide Web. The advantage is your disk space is saved. The disadvantage is your data is being stored in place with thousands of other people and organizations there. Anyone can try to steal your data. Your data security can be compromised. You will study your case studies on your own. These are very simple case studies. You will easily understand them. You will be able to learn them very quickly. Once you go through the lecture that we are discussing here, you will be able to understand these case studies very easily. In section 2, various kind of system softwares have been presented. As we mentioned in the start of the lecture, system softwares are such kind of softwares which help your applications run. So your operating systems can be system softwares. Various kind of utilities can be system software. The languages in which you program can be system software. Modeling tools can be system software. Such kind of software with which you program can be system software as well. So a lot of kind of system software that we are going to discuss in next few minutes. You have to understand why system software exists. If you look at slide number 23, since all of you are computing and students are such students who take computing courses, so you understand that this computer hardware does not understand the language that we speak. It understands zeros and ones. In computer hardware, there are circuits. Those circuits turn on or turn off. So when they turn on, it is 1. When they turn off, it is 0. So for example, if it is on, off, on, it is 101. If it is on, it is 111. If it is on, off, off, it is 100. That is what hardware understands. But we, the general people, don't know what kind of combination of ones and zeros becomes. So we write our commands in English. For example, print command. For example, save command. This is in English. But hardware doesn't understand English. Then we type print command. The end user gives the command to the application software. Application software accepts the command, but application software doesn't know the ones and zeros language, binary language. So application software interacts with the system software. System software knows how to transform that command into the language that hardware understands. It transforms that command given by the user to application software into binary code and gives it to computer hardware. Computer hardware understands it and generates some output, again in binary, and gives it to the system software. System software transforms that into the language which application software understands and gives the output to application software, which displays it to the end user, who are we. So if there is no system software, we users and our applications cannot communicate with hardware, both for input as well as for the output. That is why we always need system software. Now in system software, the most important kind of system software are operating systems. Now operating systems perform many tasks. On slide number 24, you see the first task that operating system provides is that we mentioned just now. Operating system helps general applications communicate with the hardware. General purpose applications, application software communicating with the hardware through operating system. That is what we just discussed. This is the first task. The second task is resource management. Now you see that when you are using a computer has a defined amount of resources. It has certain amount of RAM, it has certain amount of processing power. All of the specifications of the computer that you have are its resources. Now, if many applications are running without control and monitoring of someone overlooking these applications, this is like you leave 20 children in a room and don't have any supervisor over them. Those 20 children will start fighting with each other for everything. Like if we have 20 children in a room and no teacher, and we put one ball in that room, all of the children will try to grab that ball. But if we have a supervisor, that supervisor will ensure that every child gets ball to play. Operating system plays the role of that supervisor. In our computer, many applications are running at the same time. For example, right now, Blackboard is running. Maybe you have also your compiler running at the same time, your word processor running at the same time, some other applications running at the same time. If there is no operating system, all of the applications will try to grab all of the resources. Operating system manages the resources between running applications so that all of the applications work smoothly. And then operating system performs the task of file management. You can manage your files with the help of, like you see, if you are using Windows or any operating system, you see you can create folders. You can create subfolders. So it creates a hierarchy. There is a computer, then there is a D drive. In the D drive, there is this folder. In this folder, there are subfolders. In subfolders, these are files that you have maintained. So all of the file management is done by the operating system. Why it is done by the operating system? Because if operating system does not maintain the addresses of the data that you have placed, it cannot access them easily. With the help of file management, it creates hierarchies so that it is easy for it using depth down algorithm, using top bottom algorithm, using parallel search algorithm, various kind of algorithms it can perform efficient file management. This is another task that operating system does. And it does task management. Means if several applications are running, all of those applications have different tasks to perform. So these tasks are performed with the help of operating system, because applications cannot directly communicate with hardware. The tasks will be managed by the operating system. Now operating systems give us the power of multitasking. Means at the same time various applications can run. When there were no operating systems, the computers could do only one job. Now with operating systems, computers can do many jobs. You can play music, you can write documents, you can do programming, you can maintain database. All of these things can be done. This is called multitasking. With operating systems, you can do multitasking. Multitasking can be done in many ways through multi-programming, time sharing, time stamping, virtualization. All of these are programming concepts. Like if your operating system gives resources to one software for one particular chunk of time, and then it takes the resources and gives to another software to do their task. And this switching is done so fast that you cannot notice with your naked eye that resources are being switched. It is called preemptive. And if it is like that, one software gets the resources and others wait until it has done, and when it has completed its work, it hands over the resources voluntarily to another software. This is called cooperative multitasking. In some operating systems, we achieve virtualization. Means that operating system divides the resources of computer in such a way that it creates 10 virtual computers, for example, and it gives one small virtual computer to one application, second to another application. So all the applications use those resources which are part of that virtual computer. They don't encroach on the other virtual computer, and all of the applications work in parallel, independent at the same time, because everyone has their own virtual chunk. So with virtual machines, computers can also perform the task management. There are two kinds of operating systems. One are those operating systems which are specific to a particular hardware. So, for example, if you look at Mac operating system can only run on the hardware developed by Apple. If you look at Windows operating system, it can only run on PC computers. PC computers is the name of those computers which follow the standard of computers designed by IBM. So since Windows was first developed for computers which were developed by IBM, so any computer that you use today, which is called a personal computer, runs Windows on it. A personal computer does not run Mac on it, and an Apple computer does not run Windows on it. Similarly, all those machines which are developed in collaboration with Google run the Android operating system. These are not open source operating systems, means you cannot change them. So if you buy Android, even if it is free, you download it, but you cannot change it. It is not open source. But then there are second category of operating systems like Unix, like Linux. These are the kind of operating systems where you can install on any hardware. You can change them, you can modify them according to your like and dislike. These are called open source operating systems. We have already discussed what open source software are. Open source softwares are where you have the full authority of the software that you are using. You can change them. Source code is available to them. You can change them, modify them, reuse them. These are called open source software. So there are many open source operating systems, just like there are many open source software like OpenOffice is an open source office tool where you can not only create documents, you can not only create spreadsheets, even you can change the code of the software that you have downloaded, you have acquired. But then Mac operating system is specifically designed for Mac computers. You cannot change it. It is not open source software. Second category of system software are utilities. Like if you type Control Alt Del, you get the Task Manager. Now what is Task Manager? Task Manager is a utility through which you can manage your computer. You can kill the applications which are not responding. You can reassign the resources. You can manage the threads of the applications that are running. You can create a new thread. This is a utility. Similarly, for example, when you start your computer, at the bottom right of your computer, you see the time and the date. This is a utility. These are the various kind of system software which are running so that your computer performs better for you. Middleware is the kind of software which helps one software communicate with another software, because those two softwares cannot communicate with each other directly. For example, there is a software package called Corba. Corba is the middleware. If you have a distributed kind of application, that distributed kind of application will be running on heterogeneous operating systems. So we have Corba. Corba helps all of those different operating systems communicate with each other. This is a middleware. A middleware is a software which can help one software communicate with another software. These softwares are diverse, means they don't understand each other. Right? So with the help of middleware, both the softwares can communicate with each other. Last topic of today's lecture is, this chapter is programming languages. There are various kind of programming languages, and these programming languages have been designed in various times. There is first generation language, machine language. Machine language is the binary code. Machine language is the code that your hardware understands. Second generation of language was assembler languages, like assembly. This language has a few instructions, like assembly has no more than 30 instructions: load, instruct, write, read, remove, etc. So you can only use those instructions. You cannot use any other instruction. With this assembly language can directly be transformed into machine language. So when you use any of the language that we work with, C++, Java, .NET, any of the languages, when we write code, that code is first transformed into the assembler language. That assembler language is understood by the operating system, and operating system transforms this assembler language into machine language. Third generation of languages, high level languages, are such languages which can help the users writing code in a language that they can understand, but it can only perform a particular kind of operation. Like BASIC can do only some kind of operations. COBOL can only do some kind of operations. You cannot make any application using these languages. You can only write code for a specific kind of application. Fortran, for example, is a formula transformation. You can only write mathematical operations in Fortran. You cannot do anything else. You cannot make a game in Fortran. These are the languages where code was written in English, but that code was for a particular purpose. Fourth generation languages were such kind of languages where you wrote code in a particular style in English, and you could do any kind of application development with fourth generation languages, and your computer could interpret them and execute them. Fifth generation languages are such kind of languages where you write in pure English, and your computer understands what you want out of that. These are very high level, advanced level languages. For example, when you make frameworks, management information system frameworks, or portals, or jackets as they are called, so that those can be tailored by end users. These are called fifth generation languages, where you have the model, you have the skeleton, you simply modify it according to your understanding, and you get a new application. Object-oriented languages are also fifth generation languages. These are such kind of languages where you don't follow a particular procedure or a structure, but instead you write your program in such a way that everything that you want to do is in the form of an object. That object has its attributes and its operations within it. So there are multiple objects interacting with each other. This helps in reusability, and this helps in information hiding and security as well. So more detail of these will be in your programming courses. Then there are some languages in which you develop pages for World Wide Web. These are called web languages and services. HTML, XML are the examples of languages in which you make web pages. Now if you want to make a web application, then you need some other kind of languages like Java, like .NET. With the help of Java and .NET, you not only make web pages, you make web services. You make software which run on World Wide Web. So if you see cloud applications like Google Docs or like cloud services provided by Amazon or Microsoft, you will see that these applications are made by Java. These are made by .NET. For example, this Blackboard. Blackboard runs on World Wide Web. This is a software. This is not a web page. This is a software which runs on World Wide Web, and Blackboard is made in Java. So you see, when you start Blackboard, you need Java to run on your computer. If you have Java on your computer, Blackboard can run. Otherwise, it cannot run. So it's a Java-made product which runs on World Wide Web. It's a web service. Blackboard is a web service. You have not installed Blackboard on your computer. You are using it using the browser, right? It's a web service. This is on slide number 36. This is the whole cycle of how web and internet languages work. And then there are softwares which help these languages develop softwares for you. A language cannot just run in the air. Most of the languages need some software in which the coding is performed. For example, when you are doing coding, you need compilers. Compilers are a kind of system software which are needed by programming languages. You need interpreters. You need various kind of programming tools, and now there are even case tools as well. You don't need to write code. You just create a model, like in rational rows. If you create a class diagram of your software, rational rows can create code for that class diagram. So there are case tools. All of these softwares help in programming, help the programming languages. These softwares are also part of the system software. So we have completed our chapter 4 in today's 1 hour. We have completed the discussion. Now if you have any question, you can ask the question about this particular chapter. Otherwise, we will conclude our lecture. If you have any confusion, just type it in the chat so that we can put the questions here. Your chat permissions have been enabled. If you have any questions about chapter 4, you can ask those questions. In the next couple of minutes, otherwise we will conclude this lecture. Thank you so much, Reem, for attending the lecture as well. I hope it was helpful. Yes, Fatma, kindly type your question. If anyone else has a question, they can also type their questions right now. Reem, it is like what I think you should read at least once the chapter, at least once, but then you should, then the slides will be sufficient for you. Then right now I am fast because you have your course instructors at your campuses and they will be delivering lecture about the chapters as well. So here I try to give you a second reading of the chapter so that you have two teachers instead of one teaching you. Now since I have to conclude one chapter in 1 hour, so I try to be fast. At which campus you are, Zainab? I thought you will have face-to-face classes this week. Which campus are? I will check why you don't have face-to-face classes in the MAM. I am really sorry if you don't have right now. If I knew you don't have, then I would have been slow. But even now, if you will download the lecture, its recording will be there. So you will download the lecture again and you will listen to it. You will get it more clear. Since I have only 1 hour of interaction, so I am sorry you could not understand it properly, but I have to give this lecture in 1 hour. That is why I have to be fast sometimes. If you will download the recording and you will listen to it again, you will understand it better, inshallah. Fatma, do you have a question? If you have a question, please type it. As I mentioned, if you read the chapter only once properly, after that you go into the slides, then slides are sufficient for the exam. Thank you so much for your being here as well. I really like the way you study and you put effort in understanding things. I really appreciate your effort since you have jobs and you have a lot of other things that you have to manage, and then you have classes as well, and then you come back and attend this lecture. That is also a very good effort. Thank you so much, all of you. I hope that your face-to-face classes will start at the earliest and your time will not be wasted, and you will have this support as well. Thank you so much. We will conclude our lecture now. Thank you, everyone.